So this is a short video cast about using the MikRIR impulse response measurement utility in MATLAB. This utility is designed to allow you to measure impulse responses directly in MATLAB and then to make use of all the nice plotting and analysis features in MATLAB without having to faff around with importing WAV files and everything else. It's also designed to help you to manage multiple measurements from multiple venues in a way that hopefully will make your workflow well, more manageable. So the philosophy to start with, to get an idea of how this tool should be used, is that the utility lives in some folder, and in this case it's in this folder, utility dev, which is where I'm developing the utility. There's only one file that contains the GUI, and then a folder here of supplementary code that you don't need to worry about at all. This just comes with the GUI, and this is used in the data acquisition. This folder, as I've named it, data_RAR for room impulse response, then contains a bunch of other folders which are your data storage folders. So for example, if I was going to go and make a measurement in the McEwen Hall, I would create a new folder in here, Jan 2017, 2018 we are now, for example. And within here, then all the measurements that I'm about to go and make will be stored, and this metadata will be written into each of the files as well. So as a principle, every time you go out to make a new measurement or something, you make a new folder within this data folder here, and you need to do that first. Okay, beyond that then, one other thing to add before we show you how to use it. At the moment the utility uses PlayRec, which is a third-party MEX file that allows MATLAB to speak to audio interfaces. You need PlayRec to be visible to MATLAB on the path. I've given you two compiled versions of this MEX, which should work for the majority of cases. Mackie is for Mac 64-bit systems, and W is for Windows 64-bit systems. I'm told by a number of people that these work just fine. Certainly this compiled version of PlayRec is the very one that I use on my Mac laptop. So make sure that's on the path. It's up to you to work out how to do that. I'm just including them here so you can you can easily add them. So the utility uses external interfaces such as Focusrite 2i2, Zoom F4, RME Fireface, etc., anything that's a standard audio interface that's class compliant. So you need to connect such interfaces to your computer, have them recognized by the computer before you start MATLAB, otherwise they won't be visible. Just to show you that, here's an example for me. Here's my sound cards. I can see I've got the 2i2 USB both on the output, available as an output device and an input device, so we're good to go. So that said, I'll boot up MATLAB, we'll wait for this to load, and then we're going to navigate to this folder here. This will be wherever you choose to store your utility. So here we go. Here's my utility. Workspace is nice and empty. To run the utility, you simply type it and press enter. You don't need to do anything else, and also we should see a GUI window come up. It temporarily, you may have noticed there, it temporarily adds this folder here to the MATLAB path, which contains all that code that's used for data acquisition. You don't need to worry about that, but that's what it's doing. So here we go, this is the utility. There are now two useful windows here, or tabs, for doing stuff. One is MikRIR measure, where you can measure new impulse responses, driven entirely by this user interface, which looks complicated but isn't. I'll show you in a second. At least I don't think it is. MikRIR plotter is then for doing plotting, maybe plotting of multiple impulse responses from previous acquisitions, all here. So these are kind of two separate things. and you should probably, for the moment anyway, view these as two different workflows. Either you're in the workflow of measuring new impulse responses, and this will show you the measurements you get. It will then give you the chance to export them to disk. Or you're going back to look at impulse responses you've already measured, in which case you want to use this guy here and load them. So I think I'll go from left to right here. So we'll start with the measurement tab and show you how to do this. It looks complicated because I'm giving you the possibility to control almost everything about this acquisition. At the moment, I should point out there's no way to calibrate for microphones or loudspeakers. That will be added later on at some point in this tab. So your measurements are raw, so to speak, but for many purposes that's just fine, particularly for doing acoustic parameter calculations. You don't really need to calibrate the loudspeaker. So the workflow here kind of follows from audio interface setup to sweep setup to metadata entry to measurement control and then export. So it really flows in the way I've ordered it here. These three panes here, panels, are for controlling what's in the plots. These panels here don't do anything to your raw data, they just affect what's plotted here. So the first thing to do is click this green Find Playrec Audio Devices. That automatically searches your system for audio devices, and you can then click the drop down and select your output channel, output device and your input device, and once you select the input device it should automatically map the available channels here, and you can decide which of the channels you want to acquire. So we're going to do a loopback test to measure the impulse response of the input-output DAC ADC stages. So I've got the output channel 1 connected back straight to the input with a 1/4 inch cable for this particular device. Buffer length here is something you shouldn't have to use unless your system starts to, unless you get messages in the MATLAB console here telling you that samples have been missed, in which case you may wish to extend this to say 256 or something like that. That increases the buffer size. Default is fine for most purposes. It automatically tries to find an appropriate buffer length for the input channels. So the sweep setup, all the parameters here you can probably just use as they are, as default. That's one of the advantages. Hopefully here you can easily just use it straight away. If you want to tweak things about, probably the most relevant things to tweak are T sweep dur, which is the duration of the sweep. So for this purpose here I'm going to make this a bit shorter, maybe 4 seconds. T fade duration is the input-output fade, so this is 100 milliseconds of input-output fade. That's probably fine for the moment. And then TRIR is important. That is the final impulse response duration that you are going to get out of the measurement. So you need to make sure that's long enough. Now, in actual fact, the workflow here means that this number will give you an initial final impulse response duration, but you can actually then tweak that in the export stage here so that you never lose any data, so to speak. If you make this too short, you're not losing data. It's just that your first estimate for your final impulse response might give you an impulse response that's cut off, and then you might need to extend it here. I'll show you how to do that in a sec. But anyway, you should probably use this conservatively, so if you're measuring in a large concert hall, then maybe 5 or 8 seconds is good to really make sure you've got your measurement right down to the noise floor. For this present measurement, I'm doing measuring impulse response of a device with a very, very short impulse response, so probably 1 second is, well, it's definitely more than I need, but I'll use it like that at the moment. Then you've got the volume for the main sweep, which is set in units of dBFS. So if you've got volume controls on your output device, then the actual volume that you'll get out the speaker will be an interplay of this with that volume control. That's the main sweep. So there's an option here to use what I call click sync, which I think is quite helpful. for devices that have variable latency, and that's certainly the case in my experience of using the playrate utility in MATLAB. So click sync gives a little click about, well, with a gap of the number you set here before the start of your actual main sweep, and this allows you to compensate for any variable latency from measurement to measurement. So I would leave this on unless there's a good reason to turn it off. If you find that the click is really loud for whatever reason, you can reduce this number here. It turns the click volume down. You don't need to worry about the averaging any of these three numbers here because they're not really implemented at the moment. Finally, this current B regularization, you need to probably leave that on. I would advise that you don't touch any of these numbers here either. This is to do with how the inverse filter is computed and applied. Just ignore that, but make sure you don't declick that. Okay, so once the sweep is set up, probably the most important part of the whole show here, and the reason to use such a utility, is to have metadata to describe the measurement you're doing. So in the case of going to measure, for example, well, I've just made MikRIR in Hull. Let's make a new measurement for focus right underscore 2i2. So this is going to characterize my device. So I make a folder called that, copy that text exactly, and label it under room name. So room or device, it's the device under test that this is relevant for. So that's the first thing to look at. Then the speaker ID, if you've got a loudspeaker, label it here. That might be useful later on if you want to do some post-acquisition calibration of the speaker. In the present case, I've got no speaker, so I'll put none here. Date is automatically assigned today. And then these three things here at the top of the metadata panel are the things you'll probably change from measurement to measurement. So a typical workflow would be to go to a concert hall and take maybe 10 measurements at 5 different positions or something like that. So the positionings are controlled by, well, source for a start. So maybe your loudspeaker is on the stage, so you can have stage here, or you might say stage center or something like that. In the present case, I've got my source, I guess, is the interface output, channel 1, and my receiver is interface input, channel 1. So I might label it like that. My run number then is some piece of text or code or numbers that tell me the particular measurement repetition I'm doing. So the first measurement, I might leave this as take 1. The second measurement, I would change it to take 2, and then take 3 and take 4, and so on. And each of those repetitions, so to speak, as long as you change that run number appropriately, will give you a new file here in your output folder once you export it. So it's a way of quickly measuring 10 separate repetitions or something like that. Maybe in a future version that will be automated, but at the moment it's not. Finally, source receiver distance is often a useful piece of metadata. If you actually measure that, you can put the number here in units of meters. Here it's not relevant, so I'll leave that empty. And finally, if you want to make some extra piece of note, if you want to take some extra note about the measurement, like, I don't know, sun not shining, something that might be relevant, that might be helpful for you to remember what this measurement was, you can just enter that there, and that will be baked into the metadata of the output file. So I can't emphasize enough the importance of checking and double checking what's in this metadata every time you take a measurement. That's the whole point of this workflow, is to make sure that you get files where 2 weeks, 2 months, 2 years down the line, you know what the file was, and you can deal with it appropriately. Assuming you've set that up appropriately and you've selected the channels you want here to record. So if you had multiple microphones here with a loudspeaker, you might have 4 that you need to select here. You need to tick them all. In the present case, I've only got 1 channel because it's an input. It's not a microphone, so I'll just call it direct in 1. This one I don't need to label because I'm not using it. So that is then the name of your microphone, so to speak, or in the present case there's no mic, it's just the direct input. That done, I think everything is ready to go, so you just click measure RIR. You will see this red thing goes red whilst the measurement is ongoing. Don't do anything during this time. Hold your breath. When everything's done and acquired, you should get a green light here. So let's do it. Measure RIR. So it flipped me back to MATLAB, but I can go back here and see that the measurement is live. And the data is now acquired, and there it appears here. So we'll talk about what's in here. This guy here is the raw recording. So this is one channel of audio, channel 1. So channel 1 here, the number 1, relates to that channel number ID. So that's 1. Maybe I should label that with the mic ID, but at the moment that's what it is. This guy here is what I call the raw deconvolved impulse response signal before any windowing. So this is somewhere buried in here is my impulse response plus all the nonlinear distorted components. In the present case, there shouldn't be those distorted components should be pretty small because there's no electroacoustic device involved. Start and end tell me the windowing, if you like, that will be applied so as to produce my final impulse response, which is in this window here. So if I click zoom here to select the zoom tool, I can then drag just as you normally can in MATLAB, and if I look here and keep zooming in, you'll see this sort of sync-like function that describes the impulse response of my device. And you'll see that automatically the start of my output final impulse response, which is in here, so I'll zoom in here, is this green line. So this is one of the reasons I wrote this tool, I guess, is to be able to see this live and tweak it appropriately. So I'm getting about 2 milliseconds worth of signal, so to speak, to the left, which is to say earlier in time from that big peak there. So that time there is not by coincidence 2 milliseconds, that's the number here. So the advantage of having this particular workflow is that we can tweak this around and we can play with it until we get the particular windowing of the impulse response that we want. So for example, if I was in here and I wanted to, I don't know, extend this further to the left to make sure maybe there's some earlier reflections here that have been missed for some reason, then I can change that time, maybe make it a bit longer, so it'll be more to the left. Click the replot button and it replots them. I have to zoom back in, but I'm getting an extra 2 milliseconds to the left there. And if I look in here on this zoom tool, sure enough, I've now got 4 milliseconds of kind of pre-ring before this peak. So this allows you to sort of surgically describe which bit of your deconvolved signal you're going to extract as the final impulse response. What you see in this window here is what you're going to get out when you click export. So at the moment this is way too long, probably. Don't need a full second to capture the impulse response characteristics here. Maybe I need a bit more to the left just to get down to the noise floor, so let's, I don't know, make that 10 milliseconds, and my overall impulse response maybe, I don't know, let's see what that looks like. Okay, so I'm getting 100 milliseconds of impulse response. You can see most of this is silence, so that's still probably more than I need. Let's say 0.4, 40 milliseconds. Okay, so that's probably even more than I need. There we go. So that's probably about right for this particular signal. I've got plenty of example signal from the noise floor, so to speak, if I need to do some further processing. And most of my impulse response, well, all my impulse response is really captured in this very short window of time here. So having manipulated what I'm getting here from these two guys, I'm ready to export the data. And if I click export, it will then tell me in the MATLAB console that a data file has been exported with this file name here. So the file name is constructed from the metadata. It tells me a couple of other things, and if I go here and look in here, there's my file. It's 13 meg, contains a bunch of extra data that might be useful later on. And that's it. That's how you use this window. So if I wanted to go and make another measurement, all I would need to do is change that number first, click measure again, wait a few seconds. There's my new measurement. Incidentally, it's reset these numbers here, which is unfortunate. I should maybe change that in a future version of this, but at the moment I remember the numbers. It was that, and that, and if I replot, there I go. Let's export again. Tells me in the console that another file has been baked. So you can see this is really pretty easy. Within a matter of, well, a minute probably, you could generate 10 or 15 repetitions of the measurement here if you wanted to. And in a real space, using a longer sweep, well, it would be longer, but it's still pretty fast, I think. So that is how you use this console here. One final thing here I think I'll point out is that it might be useful in some cases, for example, to look at the final impulse response you're getting here on a logarithmic amplitude scale. If you just click that, it will do it for you. There you go. And you declick it, and it undoes it. That might be implemented in future in these signals, but it's less relevant for these two, so it's not implemented at the moment. If you may ask yourself, okay, so I've done this measurement, here's my impulse response in time, what does it look like as a frequency response? Well, there isn't enough space here for a frequency response plot. If you happen to want to see a measurement you've just done and see its frequency response, you can click this tab here, pass the data to MikRIR plotter, and that will chuck the data over here and immediately plot it here with the same parameters that you inputted here, so you get the full impulse response. And on the right here, you've got the frequency response associated with that impulse response, and you can use similar pan and zoom tools to look around. And you see, sure enough, this is pretty darn flat. As an impulse response in frequency, it's, well, extremely flat. And this is a 60 quid interface. That might be useful. Okay. I suppose one final workflow is that you may go through all of that and say, okay, I immediately want a WAV file that I can look at somewhere else. That's what this pane for is here. This option here, in fact, in the case where you've only got one file, these two things do the same thing. If you've got multiple files, they do different things. Probably this is the one you want to do most of the time. Norm the loudest RR to 0.1 dBFS, so that just adjusts the volume of the output WAV, so it's almost at clipping but not quite. This will bake for you a 24-bit file at the sample rate that you chose to use, which of course you set back here, so at the moment there are 2 sample rates supported. If I just click export, let me just check actually, what am I doing? Yes, if I just click export WAV here, it will bring up a pane here with the option to, well, let's put it in here. Let's call it that. You're not supposed to add the .wav extension. Save. And there it is. So that's a very small WAV file. It's 48 kilohertz. As I said, that was our measurement rate, 24 bits. I can just open that to show you. And there it is. 40 milliseconds of system impulse response, immediately available in as an Audition or whatever other platform you want to use. So I'll make a short second video in a second about using the plotter and what that does. But that's enough for this basic how to